So we're going to stay in the world of the mysterious world of linear A for this talk, but we're going to look more at the palaeographic aspect of it. And we are going to present a database we made to record the linear inscriptions. Esther will do the talking about this part.
So in this talk, we are going to present the first version of an interactive database of linear A inscriptions. So let us start with an overview of linear A, and please do bear with me if this information proves redundant now. So linear A, as you may have known by now, is a logosyllabic writing system used in the Bronze Age A in the time span 1800–1450 BCE. It is attested primarily on Crete, but also sporadically in mainland Greece and the Aegean Islands, as you can see from the map. Linear A writes the Minoan language, which is still undeciphered, of course, or partially deciphered due to its relationship with Linear B, a script developed out of Linear A in order to write Greek and successfully deciphered in 1952. Hence, by retrospectively applying to Linear A the phonetic values we have got for Linear B, we are able to read Linear A text, at least with an approximation. The little we understand of the Minoan language leads us to assume that Minoan is not related to any linguistic family so far known, unless the previous speakers are able to decipher it, hopefully enough. Linear A shows two main contexts of use, administrative and non-administrative. Most inscriptions fall into the category of administrative documents, and here there are a variety of clay documents functioning as records of economic transactions for the bookkeeping of the palatial administrations of late Bronze Age Crete. On the slide, the most common document types are shown, not to scale. These are tablets, recording the flow of incoming and outgoing goods, roundels, understood to have functioned as some sort of receipts, and sealings of different types, usually attached to goods when transported. However, Linear A inscriptions are also attested on a variety of other supports, such as stone, metal, and pottery, some examples on the slide. In most cases, these objects and the inscriptions they bear were used in religious contexts. At present, the database only contains administrative documents, more precisely, the tablets found at the most prominent sites on Crete, the one mentioned in the previous slide, alongside a few other document types. However, the long-term plan is to implement the database by adding all inscriptions recovered so far in order to make it as comprehensive and exhaustive as possible. So, where are the inscriptions available for us to view? To start with, the main corpus of inscriptions on any support consists in the 5 printed volumes published by Louis Godard and Jean-Pierre Olivier some 40 years ago. This is available in print form only, although scans have recently been put online by publishers. The corpus shows a black and white photo of the document, a drawing, and 2 transcriptions. The first one, top right, is faithful to the original layout of the text, while the second one, bottom right, shows standardized sign shapes along with a functional arrangement of the text. In the first column, there are words. In the second column, there are logograms. The corpus was a considerable achievement for the time, allowing for an accurate and detailed interpretation of the material. However, as it does have limitations. First, it is not intended for a wide readership, and it is only accessible to those who already have a basic knowledge of Linear A, given that neither a transliteration nor a transnumeration of the inscription is given, but only a transcription. And for your information, Linear A signs are usually best known by their classification number, allowing quicker retrieval. So, in order to read a text, the sign shapes shown in the transcription have got to be checked against the standardized list of Linear A signs available at the beginning of volume 5. Linear A is composed of some 180 simple signs representing a graphic and phonologic unit, and some 164 complex or composite signs, which are the combination of 2 or more simple signs. On top of these, there are some 30 fractional signs, right-hand table. Another limitation of the corpus is its very format. In fact, a printed edition does not allow to carry out any statistical and comparative analysis of sign and sign sequences, resulting in slowing down comparative linguistic and palaeographic research, unless one painstakingly collects their own dataset. A digital approach, therefore, is clearly needed to make the most of the evidence and to promote further linguistic and palaeographical research, allowing for complex searches. So let us start with a practical example to see how a document is presented in the printed corpus and in our database. On the slide, you can see a tablet from the site of Hagia Triada, located in central South Crete. The original tablet, colored photo, is preserved in the Archaeological Museum of Heraklion and is standardly edited in the corpus as illustrated earlier. Now, let us look it up in SigLA. So this is the home page of our database, SigLA, where you can do a number of different searches. To look for a document, we need to go for a document search. Now, we want to look for Hagia Triada, number 13, search the corpus. "13" is there. On the page of each document, you can see the metadata associated to the tablet, along with the tablet and the drawing of the tablet itself, based on the edited corpus. To circumvent the copyright issues surrounding the original drawings, we decided to make our own drawings of each document as faithful to the original as possible. This long process turned out to be fruitful, as it allowed us to separate distinctly each and every sign drawn on the tablet's surface. Each sign is colored according to the function it performs on the document, color code. This can be, for instance, a phonetic sign, like here, ka, u, te, ta, or a logogram or ideogram, like this one, logogram for wine, or even numbers, these lines, or fractional signs. The document can be displayed either in sign view, like it is now, or in word view, that we will go to later on, grouping together the signs that are part of a single word. In both cases, by clicking on a sign or on a word, you can see the other occurrences across the corpus. For instance, when clicking on, let's take as an example, U, by clicking on the sign, we can see all the different variants of the same sign across different sites. We've got here Hagia Triada, Chania, Zakros, Malia, and you can appreciate palaeographical variation across sites. Going back to Hagia Triada 13, we may want to move now to word view. By clicking on a word, here words are highlighted in different colors again, like in the previous view. And by clicking on a word, we can see all the attestation of such word in context. Let us take, for example, last line, kuro, which means total. Sorry, oh, I cannot click on the, oh yeah, there is a little bug. Can you help? Sorry for this little, oh, there we go. So here we are redirected to a page showing all the attestation of this word, kuro, in the documents already present in the database and the contextual occurrences. Going back again to Hagia Triada 13, we can see that this tablet has only got simple signs on the tablet surface, and the complete list of simple signs is also available in our database under sign list in the home page. There we go. SigLA sign list displays both simple signs and composite signs. However, the signs listed here are not shown in an abstract, standardized shape as in the edited corpus, but they represent actual attestations. For example, if we click also here, if we click on a sign, we are redirected to the web page showing all the attestation and the palaeographical variation of that given sign. There we go. With respect to composite signs, composition and composite signs are also listed there after the simple signs. Composition arrangements are also specified there. At the bottom of each sign, you can see the different constitutive components each composite sign is made out of. And in this way, composite signs are broken down into constitutive components for easier understanding of their structure. In this respect, we can also do a complex search looking for all attestations of a given sign in composition. For example, if we go back to the home page, we do a sign search. We want to see sign A302 plus, which means in composition. We search the corpus and we see all the attestation of such sign, which is this curvy sign, in composition with other signs across sites. Okay. We may now want to look for a tablet showing composite signs then. This time, we will do this by using the quick search function and not the document search function. We want now, quick search, we want now to see Aggia 14. There we go. This tablet contains a number of composite signs, for example, A608, which is this one, but also here, one in combination with the 302 shown before, and also this one. So if we click on a sign, again, we can go and see all the attestation of such sign. In this case, it's not very frequently attested. Going back to Aggia 14, this tablet is also interesting as it shows an erasure, which is this sign here. If you can zoom in with your screen, you can see that there is a sign which was written underneath a second one written on top. And the first sign was erased. It is possible in SigLA also to carry out a search to look for all attestations of erasures, which means signs being cancelled after having been written. To do so, we need to do another complex search. We go to Home, Sign Search. We do an advanced search by looking for any sign which is an erasure. We want it displayed in any document containing the occurrence in a contextual view, and we search the corpus. So here, all the documents showing erasures are shown according to site. There we go. So we would now like to give you some more details about the database construction process, and now I hand it over to Simone.
Yes, so given the palaeographic nature of the database, we thought it was better to start afresh and develop our own software that we called SigIL. And so SigIL deals with the three aspects of the database, which is the data representation, how to represent documents and signs, the data entry, how to import drawings into the database, and data manipulation, so displaying the document or searching the database. So the whole thing is written in OCaml, and as the source file of the database for the drawings, we use the Crete software, which is a drawing software. So the overall architecture of SigIL is as follows. So we have the source corpus, which is a set of Crete files that are annotated with document metadata, for instance, location or kind of document. And the crucial point of our approach is that each sign is drawn on a separate layer of the Crete file that allows us to crop every sign to a different image file. And that whole process, plus gathering all of the metadata, is done by the importer, which turns these drawing files into a database, which is composed of the JSON files for the metadata, plus all of the image files for every tablet and every occurrence of a sign on each tablet. And so all of that database is whenever you connect to the SigLA website, is shipped to you, and all of the processing, all of the displaying is done on the client side. And so the whole interface that you've just seen is written in OCaml and has been compiled to JavaScript to run directly in your browser without you having to install anything to access the database. And that very simple architecture is possible because the corpus is relatively small, about 1,000 documents. So there is no need for sophisticated architecture. So one of the aspects that was quite difficult in writing the software is how to represent the data, because there are many objects involved in the database, and some of them are usually referred by the same word. For instance, sign is a word that can mean different things in different contexts. So for instance, we have the notion of abstract sign, for instance, AB22, which is the sign for goat. So this sign has a number, 22, a prefix, AB. It may have a phonetic value, so AB22 doesn't have one. It may have other properties, for instance, Latin transcription, etc., etc. But then that abstract sign can be realized in different ways, and that's called a sign variant. So for instance, the AB22 has two variants, one for the male goat and one for the female goat. And then we are still in an abstract world here, because in practice, if you have a set of stroke on the tablet, then you might not be able to read it, or it might not be a sign that is actually in the corpus. There are some occurrences like this. So we have to have a notion of sign reading, which means the interpretation of a set of stroke. So it can be either a sign variant if we manage to actually read it, or it can be unreadable or unclassified. And then a set of stroke that can be read, it's also in the end occurring on a tablet. So that's what we call a sign attestation, is a set of stroke that represents a unique sign on a document. And so that has a sign reading plus some contextual information about the attestation within the tablet. So for instance, the function, is it part of a word, is it a logogram, where is it located in the document, etc., etc. So in general, we have to take into account imprecision in the data, because of course, as you have seen, the tablets are somewhat fragmented, and so some readings are not certain, and the word boundaries are a bit fuzzy sometimes. Another aspect that we had to also take care of is how to search the data. And we wanted something that was quite powerful, but at the same time quite user-friendly to do kind of complex data searches. And so what we come up with is a way to build complex searches interactively from small blocks. So for instance, let's say that you want to search for documents containing long words. So let's say words longer than five signs. So then in natural language, you would write this query as, I want to search for documents containing at least one word of length greater than 5. And the way we interpret that query is by identifying blocks in the search. So for instance, containing at least one word is a property of documents. Then length is also a property of words. Then greater than 5 is also a condition on numbers, which are here will be the length of the word. So under the hood, that natural language sentence is actually represented as a simply typed lambda term, which is a little functional program that's very adequate for representing these little queries. And that extensible system allows easily to add custom complex queries by just adding new atomic blocks like the ones I've shown you. So I'm going to briefly show you how this can be input in the database. So I'm looking for a document, and so I add a new criterion, and here I can choose among all the blocks that have been implemented so far. So here I'm looking for contains one word satisfying. Then now I need to add a criterion, but not on documents anymore, but on words. I want to see which words, what is the criterion that I'm looking for. So here it's something that's about the length of the word. And now I need to input a criterion on a number, integers. So I will ask greater than 5. And then I get the results. And I can see that those are quite big tablets, because 5 is quite a long, quite a great length for linear A words. And that's all for my part.
Okay, so to conclude, we would like to pinpoint some of the potential future pathways of research that SigLA will allow. First, it will be possible to refine the linear A sign repertory by being able to clearly differentiate between signs and their variants, and at the same time having a better global understanding of the structural characteristics of the writing system. This will ultimately lead to the appreciation of how many signs do represent the core of the writing system. Second, SigLA will allow to carry out research into scribal activity, which will result in a more thorough and reliable identification of scribal hands, as well as getting an idea of the overall number of scribes at work at a given site, and the identification of possible scribal writing traditions and their spread across time and space. This, in turn, will allow to throw light on matters pertaining to the acquisition and transmission of the writing system. Third, in the long term, the database will also display information about the physical appearance and manufacture of the documents, that is to say, pinacological features, such as erasures, already searchable on SigLA, presence or absence of ruling lines to guide writing, presence of word dividers, density of writing on the writing surface, as well as textual arrangement, size comparison, presence of cuttings if a tablet was cut after being inscribed. All this data will give us key information about the tablet manufacture process, as well as the editing of the text itself. Last but not the least, all these features, taken all together, will allow a more sophisticated and thorough palaeographical comparison for the evaluation of the degree of palaeographical similarities and differences across sites and within a single site, with the possibility for each and every user to narrow down their analysis to specific features by customizing their own data set based on their own research interests. We hope that SigLA will make a significant contribution to the field by proving a useful, open access, interactive tool, allowing researchers more accurately to look into the palaeographical, epigraphical, pinacological, as well as linguistic features of the linear A writing system of Bronze Age Crete. Thank you very much for your attention.
Thank you very much for this very interesting talk and very interesting work. I have a few questions, but before a short one, obvious one by myself. In 1997 already, a proposal has been sent to Unicode on an encoding of linear B. It was based on work by Ventris, Hooker, Chadwick, and Bennett. And this proposal was accepted already in 2003. So you have now a table with syllabary and another table with ideograms. What is the level of compatibility with your proposal?
So at the moment, we have not integrated the Unicode specification. That wouldn't be very hard. You would just assigning in the sign database the Unicode point for every sign. And the reason we haven't done it is because we are really focused on the palaeographical variant of each sign, which goes against somehow the Unicode version that kind of wants to have a standardized version for each sign. So for our purposes, at the moment, we didn't feel the need for that. But in the future, we would like to add automatic transcription of tablets, which we haven't done yet, and that will probably use the Unicode version.
Yes, but if I understood, there are composite signs. Yes. So how do you encode composite signs with Unicode?
So that's I think there are a Unicode sign also for composite signs, if I remember correctly. But also there are maybe some way to do it with ligatures. I'm not so sure about this. Yeah.
The problem is, if I can just add a comment, the problem is that most composite signs are actually apaxes, so one-off attestations. And I think that in the long term, we have to rethink the way in which we take these signs. So maybe they are just combination signs. So I don't know if we can just put this into the Unicode. I don't think there is really a need for composite signs. Are a bit of a question mark at the moment, because the linear A core is basically the simple signs. So I think that composite signs may require a different approach. they are not signs stricto sensu, like single graphic. They could be words. It's very likely that they could represent words. So in this case, we have to remove them from the sign list and take them as additional features. So yeah, maybe we may want to have a chat with the people implementing Unicode at the moment, yes, or talking about how to deal with the complex signs of linear A.
Interestingly, there are also some composite signs which are not a linear composition of signs. So they are not one sign after the other. They are like fused signs where one sign goes inside the other. So that will be harder to represent using Unicode, I guess.
Yeah.
Okay, thank you very much. I have a first question by Kevin Donnelly.
Hiya, this was really interesting work, and you've done a great job in the database. I just wanted to ask a quick question probably to Simon about how did you actually get the original drawings? You'd mentioned that you'd redone them manually yourselves. Was that in Crete? Did you trace them or did you draw them from scratch or what?
Actually, you studied the
That was me.
Oh,
so, sorry. So I am basically the linear A expert with more of an linguistic / archaeological expertise, while Simon is the computer science and the wizard behind behind the database. So what I did is that using my knowledge of linear A, I was able to remake the drawings by singling out every and single sign on the tablet surface and all the different features, and to classify them as either single signs, composite signs, and giving them a function if it was possible, like syllabogram or logograms, and telling Simon what's the word boundary, or adding information about pinacological features, so like word dividers, erasures. So I added all this information on Crete and made the line drawings, and then Simon was in charge of turning all this information into like the database. Yeah. So it was a very long process, and a long tablet could take up to 1 hour, if not more, to make.
Yeah. So you took a photo. You had a photograph of the tablet or something, and then you traced over it. Was that it?
Yeah.
Yes.
Yeah.
Yes.
Yeah. Okay. Fine.
So we try to make the drawings as faithful to the original as possible. Yeah. However, we are very aware of copyright issues. So also in the about web, in the home web page, we say that these drawings and these searches are only for personal uses in a way. And if you really want to be extra sure about the placement of the strokes or the correctness of a variant, we always suggest going back to the main corpus, the Gorilla 5 volumes. But the printed corpus will not allow you for making for seeing palaeographical charts in comparison. So this is just a device, a tool. Yeah. Drawings are made at their best, but then go back to the corpus.
Okay, that's great. Thanks very much. It's lovely.
And a few questions by Francesco Perono Cacciafoco.
Yeah, thank you very much. It's wonderful, beautiful. I always wanted something similar, so it's great. So the questions are just technical. I wrote them in the chat. How do you deal with the possible transcriptions of linear A? For example, Kuro, the usual classical total. I mean, do you accept the transcriptions or the possible
for now,
transcription?
We have a database of abstract sign where every sign may be assigned a phonetic value. And that allows us to show transcription of words, but of course, that database of phonetic values can be changed, or according to. For now, we have taken the standard phonetic values.
Yeah, because this is the usual problem, so it's perfectly acceptable. Just to know how to deal, in your opinion, with that. Yeah. My second question was about: do you know? Of course, you know the Linear A Explorer by Robert Hogan.
Yeah.
How do you deal with that? I mean, what do you think about that? Database?
So honestly, we came across this database when SigLA was already under construction, and we noticed that there are many similarities. Although we realized that we decided to move away from that website Explorer for two main reasons. First, because the Explorer is making use of the real corpus, the scans of the corpus. And this is not, this goes a bit against copyright. And in my previous experience, I've got issues with copyright because I'm trying to publish a book on linear A and linear B, which has got a lot of images, and I had to ask permission for the different archaeological schools, and that requires a lot of fees. So in order to move away from the copyright issue, we decided to remake all the drawings, and this is very time consuming. But in this way also we are separated for that, and everybody can use a website without having any issues.
Yes.
The second point is that, for instance, by drawing signs on separate layers, in this way every and single sign will results clearer and neater. So we don't have like a cropped sign with all the inclusions from other close by signs. And you can really see the different constitutive components of each sign. And thirdly, we are also thinking of implementing the database by adding pinacological features, as I said. So like lines that were used to guide writing, the presence of word dividers. So all those information that are pertinent to the tablet manufacturer and are not searchable in the Explorer. So I would say that all in all, they could be mutually supporting each other. And if you want to see the corpus as it is, there is the Explorer, although we have to be conscious of the copyright issues, while our database will give more free open access and slightly different kind of information.
Yes, the legal status of the Explorer is unclear to us. Very unclear.
Yes.
I
agree with your approach. I agree with your approach. I would have done the same. It's beautiful. Congratulations.
Thanks. And I hope it will be also useful to you, because there's like to try and clean up, so to say, the sign list.
Yeah. That is great.
In Python. Thanks.
Very great. Bravo.
To you.
And I have a last short question for Simon. So you're using lambda calculus, which is normally used in Montague formal semantics. Are you inspired by formal semantics? Do you want to go up to the semantic level, or is it for some other reason?
So that's because my area of expertise in computer science is semantics of programming languages, in which we use the lambda calculus a lot. But that's just a tool to represent those complex queries. But I think it's better to stick to this kind of form that forces the structure of the queries, so that it's much easier on our side, and also it doesn't confuse the user, because the user exactly knows what he can express and what he cannot express without the use of a natural language analyzer. That might be a bit counterintuitive, because it will not be perfect, of course.
Thank you.